Ladies and gentlemen, welcome to our Math119 Section 3.1 Number Systems introduction. This is my lovely looking cousin here. So ladies and gentlemen, in this section, Section 3.1, we're very interested in numeration systems. We are very used to base 10 numeration, where the ones digit is a unit. The tens digit, each value represents 10. The hundreds digit, each value represents 100, and so forth. Well, there are many other numeration systems. There are actually quite a few ancient systems. We won't really take a look at them, but we're interested in these other base systems. Base 5 is a common one, and so in the Math Activity to Start section 3.1, they talk about base 5. And so in base 5 and in any number system, we have these different things. We have the units, the longs, the flats, and the long flats. So in base 5, a unit is a unit. In any base number system, a unit is one square, one thing. In base 5, the next unit or the next placeholder up is called a long, and it is 5 by 1 or 5 units. And so in base 4, it would be 4 by 1. In base 6, it would be 6 by 1. In base 10, it's 10 by 1. The next placeholder over is that of a flat. And a flat in base 5 is 5 by 5 or 25 units. A flat in base 4 is 4 by 4. A flat in base 10 is 10 by 10. And then the next placeholder over is what's called a long flat. So in base 5, we have 5 of these 5 by 5s, or 5 of the flats. So we'd end up with actually 125 units within a long flat. So one of the things that we're very interested in mathematics is to be efficient. And so in these base number systems, we use something called the minimal collection. So in the second problem, we're shown two different collections that contain 36 units. The first collection is not a minimal collection. The second is. So when we look at the first collection, we notice that we have 1, 2, 3, 4, 5, 6 longs, or 30, and then 6 units. Those 6 longs could be rewritten as one flat, which is a 5 by 5 with an additional long, and then we could rewrite these 6 units as one long and one unit. So what we've done is we used the fewest pieces possible, the minimal collection, to write out the number 36. The 25 from the flat, the 10 from the 2 longs, and 1 from the unit. When we write this down, the way that it's written is 1, 2, 1, base 5. And so these numbers that you see here, the 1, 2, 1, these do not represent the number 121 or 121 units. That's incorrect, because obviously we just had 36 units. What it represents is a placeholder. So the first one represents the number of flats. The 2 represents the number of longs. And then this 1 represents the units. They are purely placeholders. And then by having that number 5 written there, that helps us to know that we are talking about base 5. Now when we write a number that is not in base 5 but is in base 10, all we do, if I were to write 200, if I were to write the number 235, I don't normally write 10 to say that I'm doing base 10, but I could, and all that would mean is that the 5 is in the units, the 3 is longs, and the 2 is flats. And we'll talk more about base 10 here in a moment. You will also be asked in one of your problems to take a look at a whole number, in this case 75,063, and to rewrite it into expanded form. Well, we know from our experience in base 10 that the 3 is the units, 6 is the tens, 0 is the hundreds, 5 is the thousands, and 7 is the 10,000ths digit. To rewrite that into an expanded form, what we have to do is we have to find out individual products. So the 7 is 70,000, or 7 times 10,000. The 5 is 5,000, or 5 times 1,000. The 0 is a placeholder, so it's 0 times 100. 6 is 60, or 6 times 10. And 3 is 3 times 1. So we rewrite this as the expanded form where it is the sum of all of these products, which would get us back to our original whole number. There is a second way that we can write this expanded form, and here it is. All that this is doing is replacing these expanded 10,000, 1,000, 100, 10, and 1, and replacing them with an exponential form. So the 10,000 instead is represented as 10 to the 4th, the 1,000 is 10 to the 3rd, the 100 is 10 squared, the 10 is 10 to the 1st, and the 1 is still 1. We could actually write that as 10 to the 0. But that is a different way that we could write these numbers in expanded form. So the last thing we'll consider here in this brief video is taking a collection of pieces, in this case base 10, and hopefully this Star Wars lightsaber doesn't distract you too much, but we take this collection of base 10 pieces and we want to rewrite them as their minimal collection. And so we have one flat, another flat, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 longs, and 12 units. Well, we can regroup, collect these up into larger pieces. So 10 of these longs can be rewritten as one flat. So now we have 3 flats. Well, we're left with one of the original longs, but these 12 units, 10 of them can be rewritten as a long. So now we have 2 longs, and we're left with 2 of the original units as our 2 units.